Algebra 1, continuing to solve systems of equations. Our third method, our second algebraic method, is something called elimination, okay? So if we look at this, I have an equation 5x plus 4y is equal to 20. According to the addition property of equalities, I could add the same thing to both sides. So if you were solving this, you could subtract 4y from both sides, something like that. Now, if I have another equation, so when I have an equation here, I'm assuming that this equation is true. If I add another equation to it, that's my system of equation. I'm assuming that both sides of that equation are equal to each other. So what I can do is I can combine both of these equations. So you're adding the same thing to both sides. So if I write both of these equations down, 5x plus 4y equals 20, negative 5x plus 6y equals 30, I can add both equations. What that does for me is when I add the 5x and the negative 5x, that goes away. Then you get 10y is equal to 50, and therefore, that's what the little three dots are, therefore y is equal to 5. So now, without graphing or without substitution, I know that y is 5. So all I need to do is plug that back into either equation. So if y is equal to 5, let's go back to our first equation. 5x plus 4 times y is 5, equals 20. That means that 5x plus 20 equals 20. So 5x equals 0, or x equals 0. So the solution to this system is just 0, 5. Okay. So again, it's an algebraic method. I did not have to graph, and it allows me to solve the equation. So if I look at this equation, when I add these two equations, I know that it's going to eliminate the y. So this is solving by elimination. So when I add both of these equations, I get 3x equals 9. Therefore, x is equal to 3. Go back to either equation, x plus y equals 7. Well, if x is 3, 3 plus y equals 7. Y is equal to 4. So the solution, x equal 3, y equal 4. So the point 34 is my solution. Now, let's look at this one. I know I can add and eliminate y. How could I eliminate x? Well, to eliminate x, I can multiply this first equation by negative 2. And I get negative 2x minus 2y equals negative 14. And then the second equation, now when I add these two equations, the x cancels. Negative 3y equals negative 12. So y is equal to 4. And I know that's right because that's the answer I previously got. So now I would substitute that back into either equation. X plus 4 equals 7, so x is equal to 3. So the solution here is 3, 4. So what you want to do here, just like when we're doing substitution, you want to find the variable that's easier to solve for. When I'm doing elimination, I want to find the variable that's easier to eliminate. So in the first one, I could eliminate the x by multiplying the first equation by negative 2. If I wanted to eliminate the y's, well, the common denominator between 2 and 3 is 6. I would have to multiply the top equation by negative 2 and the bottom equation by 3. So I'd have to do 2 multiplications to make that happen. It's going to be easier just to multiply the top equation by negative 2. That gives you negative 2x minus 6y equals negative 14. And then 2x plus 2y equals 6. Add these to get negative 4y equals negative 8, or y equals 2. If y is equal to 2, go back to either equation. X plus 3 times 2 is equal to 7. X plus 6 equals 7. X equals 1. So your solution is the point 1, 2. Solving by elimination. So again, in the first one, the easiest thing to do would be to eliminate the x variable. So to eliminate the x, I'm going to multiply this equation by -2. So -2x minus 4y equals -8. 2x minus 5y equals -1. Add to get -9y equals -9, or y equals 1. Then if I go back to an original equation, x plus 2 times 1 equals 4. X plus 2 equals 4. X equals 2. So the solution is the point 2, 1. If I look at the next one, I could either eliminate the x's or the y's. Let's just multiply this top equation by 2, and I get 4x plus 2y equals 4. Bottom equation, x minus 2y equals -5. When I add here, the y's will go away. 5x equals -1, so x is -1/5. Then if I go back to the top equation, 2 times -1/5 plus y equals 2, -2/5 plus y equals 2. So y equals 2 plus 2/5. So that's 2 and 2/5, or what, 12/5. So the solution is -1/5, 12/5. Now there's some times where it's going to be inevitable that you do have to multiply both sides or both equations by a variable. So in this one, let's see, I want to write that first equation, 4x plus 7y equals 12. Second equation, minus 8x minus 14y equals 12. So to get this one to cancel, I could just multiply the top equation by 2. So I get 8x plus 14y equals 24. Bottom equation, minus 8x minus 14y equals 12. When I add these together, I get what the x's and the y's cancel. So 0 equals 36. That means there is no solution here. If I look at the next one, I could easily make the x's cancel. So if I multiplied this one by -2, so the top equation is 4x minus 5y equals 20. Multiply by -2, you get -4x, and then plus 5y equals -20. Add these and you get 0 equals 0. That means that there are infinitely many solutions. Now what I got the next one, let's see. Easiest one to eliminate would be the y variable, because I only have to multiply the bottom equation by 3. So you get 2x plus 3y equals 58. -9x minus 3y equals, what is that, -145. Excuse me, no. 3 times 5 is 15, carry the 1, so 135. Okay. So now, when I add, the y's are going to cancel. -7x equals, so 135 and 58, that's a 7, 7, negative 77. So x is equal to 11. So if x is 11, go back into either equation. Let's try this one. So 2 times 11 plus 3y equals 58. 3y equals 58 minus 22. 3y equals 36. So y is 12. So the point is 11, 12. This one, easiest solution would be to multiply the bottom equation by 3. So 15x plus 3y equals negative 9. 300x minus 3y equals 9. Add together 315x equals 0, so x is 0. X is 0. If x is 0, go back to either equation. 15 times 0 plus 3y equals negative 9. That means that y is equal to negative 3. So the point 0, negative 3 is my solution. In these situations, get x and y on one side, so you've got what, 4x minus 2y equals 12, and then negative 9x, and then plus 3y equals negative 22. Check and see if I did that right. Negative 9x plus 3y equals negative 22. Now in this situation, I'm going to have to multiply both equations by something. So if I multiply the top equation by 3 and the bottom equation by 2, I'm going to get a negative 6y and a positive 6y. I can make the y's cancel. I could also multiply by 9 and 4, but I'm going to get bigger numbers. So this way I get what, 12x, so 12x minus 6y equals 36. Bottom equation is going to be what, minus 18x plus 6y equals negative 44. The y's are going to cancel. Negative 6x equals negative 8, is that right? So this means that x is equal to negative 8, 6 over negative 6, which is 4/3. Now I know x, I just need to find y. So 4 times 4/3 minus 2y equals 12. So 16/3 minus 2y equals 12. Negative 2y equals 12 minus 16/3. Negative 2y equals, what is this, 36/3 minus 16/3. Negative 2y equals 20/3. So y is equal to negative 20 over 6, or negative 10/3. So the answer is 4/3, negative 10/3. Let's see, 2t minus r equals 1, and then 5t minus 2.5r equals 7. So I've got a choice. I can multiply the top equation by negative 2.5, get the r's to cancel, or I could multiply the top one by, say, negative 5, the bottom by negative 2. So to try to only do one multiplication, if I multiply this one by negative 2.5, then what I get is what, negative 5t plus 2.5r equals negative 2.5. Bottom equation, 5t minus 2.5r equals 7. When I add these together, I'm going to get 0 equals 7, so it's going to equals 4.5. So this means there is no solution to this equation. For what value of the constant A does the system of equations below have infinitely many solutions? Okay, so let's try to get all of our x's and y's together. 2x plus 5y equals negative 8. And then I've got 6x plus 15y equals 16 plus a. So a couple of things. I can try to do the elimination here. So if I could multiply the top one, say by, or I can multiply the top one by negative 3. So let's try that. If I multiply this by negative 3, then you get what? Negative 6x minus 15y equals 24. And so in the bottom equation, 6x plus 15y equals 16 plus a. So when you add these together here, you're going to get 0 equals 40 plus a. Well, that's either going to be infinitely many solutions or no solution. The way it's going to be infinitely many solutions is if it's 0 equals 0. So that would mean that a would have to be negative 40. Okay, so I get infinitely many solutions when a equals negative 40, because that would give me 0 equals 0. The other way you can look at this answer is, if I look at the top equation to the bottom, it looks like 2 to get to 6, you're multiplying by 3. 5 to get to 15, you're multiplying by 3. So it means that in the next one, negative 8 times 3 is negative 24. So 16 plus a would have to equal negative 24 for those to be the same line, which would mean that a would have to be negative 40. A, B, C, D, and E are constants. The question is, must this system have exactly one solution? Okay, so let's look at this. If I were to multiply, so I've got AX plus BY equals D. I could rewrite the bottom equation minus AX minus CY equals negative E. When I add these together, you're going to get B minus C y is equal to D minus C. Okay. They tell me that B is not equal to C. So that means that when I solve this, y is equal to D minus C over B minus C. That means the bottom is not 0. Okay. And if I know that A is not 0, then this system has a solution y equals D minus C, B minus C. So I do know that y is equal to D minus C, B minus C. Then I can substitute in to get the answer. If you look at this, the other way to think about this is think about this first equation. Y is equal to negative AX plus D, all of that over B. In the second equation, y is equal to negative AX plus E, and all of that over C. Well, When would these things have the same slope? They would have the same slope if negative a over b equals negative a over c. So basically b and c would have to be equal, but I know that b and c are not equal. So these things do not have the same slope. So they have, I'm guaranteed that they have different slopes. So they only have one solution. Given that a is not 0, solve for x and y. So I can take ax plus 4y equals 8. Multiply the next equation by negative 1. Negative ax plus 5y equals 10. When you add these, you get 9y equals 18. Therefore, y is equal to 2. Go back to the first equation. So ax plus 4 times 2 equals 8. So ax plus 8 equals 8. Ax equals 0. If a is not 0, then x has to be 0. So x is equal to 0. Let's look at this application. A customer chose decorative garland and rangoli flower to design they wanted to make to decorate their home for Diwali. The florist has 582 marigolds and 732 mango leaves. How many of each decoration can the florist make? Okay, so they're making a garland and they're making a flower and they're using marigolds and mango leaves. Okay, so I know that the equations, I have limits in terms of the number of flowers that I'm using. Okay, so if I let x equal the number of rangoli and y equal the number of garland, then we figure out, okay, so each strand of garland has 38 marigolds. So 38y plus 132 on the rangoli, so 132x. Wait, garland. Garland was 38. So the first equation is garland. Oh, wait. Yeah, so 38 marigolds with the garland, that's 38y. 132 marigolds with the rangoli, that's 132x. So 132x equals, and then the marigolds, I have 852. Then let's go to the mangoes. So I have 58 mango leaves on the garland, so 58y plus 12x equals, and then with the mangoes, 732. So if I look at this one in terms of elimination, if I look at 12, remember 11 times 12 is 132. So if I multiply the bottom equation by negative 11, then I'm going to get the x values to cancel. So what is that? 58 and 58. So 638. So I'm going to get 38y plus 132x equal 852. And then minus 638y plus a negative 132x equals, so 732 times 11. So that's 250, negative 8052. So 638, so I get negative 38y equals, what is that, 8052. So 8052 minus 852, 7200. And if I divide that by 38, so I get y is about 189.47. Okay, make sure I did that right. No error on my part here. 638, 38, this is negative 600. So right here, this is what negative 600 y equals negative 7200, so y is equal to 12. And so if y is equal to 12, go back to either equation. I'll try this one. So 38 times 12 plus 132x equals 852. 132x equals, so 38 times 12, 396. Divide that by 132 is 3. X equals 3. So go back to the equation. It looks like I'm making 3 Rangoli and 12 Garland.